My name is Dan Delaurentis. I'm the Bruce Reese Professor of Aeronautics and Astronautics at Purdue University and also the Vice President of our Discovery Park District Institutes. So first, I think we should think about the fact that we've had automation and some forms of artificial intelligence in aviation for quite a long time through autopilots and various kinds of functions on not only commercial airline aircraft, but also even some general aviation and business aircraft. So the idea of having forms of automation and autonomous operations in a cockpit is actually not a new idea. What I think the new aerial autonomy topic brings to mind is a much more expansive use of autonomous technologies to include for aircraft that might be transporting packages, cargo deliveries, etc., as well as a more ubiquitous presence of aviation even in urban settings for things like autonomous air taxis and urban air mobility. Aerial autonomy really holds the promise for impacting almost every dimension of what we care about and value in aviation. For example, it can allow for greater safety in our operations. It could allow for greater efficiencies in high-density aviation applications, and actually even have a huge impact on the economics of the air transportation system. One example of that is that as we think about a more ubiquitous urban air mobility application, we're going to struggle to have an economic benefit of that kind of service if we actually have to have human pilots on board aircraft that may only be carrying 4 to 5 other people in an air taxi kind of mission operation. And so aerial autonomy holds the promise for really benefiting aviation in all these different ways. So all of the operations and the human responsibilities and roles in aviation play into safety. It's not just a technology issue. And so I believe that aerial autonomy does have the potential for a positive impact on safety, especially in new and emerging aviation operations where we don't have a lot of experience with a large number of aircraft in the air in a close proximity. The current aviation system, the commercial airline model especially, air traffic control is very human-centric. And in the future, in the urban air mobility area, where the frequency of flights and the density of the airspace are just so much greater, we're going to need autonomy in the air traffic control function, again with the appropriately implemented human supervision. It's always more difficult to implement a new technology in an aviation setting than in a surface transportation setting. There is a large number of examples of technologies that relate to both surface transportation, autonomous or cars, automobiles, etc., trucking, and aviation. But the key in aviation is always that extra higher bar that we have to meet in terms of safety and cost efficiency that relate to actually operating aircraft versus the surface transportation. But I do think there are synergies that we can use in these different settings. For example, every day that goes by, we are gaining more experience and data and operational context for the autonomous taxis that we actually see in some cities. And so we can translate some of those learnings into the aviation application, but always realizing that there's just that extra difficulty and extra expectation from the traveling public when it comes to an aviation application.